Hello, ladies and gentlemen. Sorry, welcome once again to our virtual classroom. Let's get started. Today, ladies and gentlemen, we are going to be going over lesson 14-2, which is solving multiplication equations. This is our 30th lesson. Yeah, here are the problems that we're supposed to do today. 7, numbers 10, 11, and 12, and number 14. By the way, if you need time to copy these down, please just pause the video. Pause the video at any point if you want to take some time to copy something down or rewind, rewatch something. Anyways, let's begin. So since we're doing equations, we know what our goal is. We've been talking about it quite a bit. And we understand that anytime we're working with equations, our goal is always the same, and that is to isolate the variable. We need to isolate the variable. That is, we want to get to the point where the variable is by itself. There's nothing around it. All right, we want that x or that a or that b, whatever the variable is, to be by itself on that side of the equation, whether it be the right side or the left side. How are we going to do that? We're going to use the opposite operation. So today, since we are working with multiplication, our inverse or opposite operation is going to be division. We know that multiplication and division are two sides of the same coin, since they are opposites in the same way that addition and subtraction are opposites. So we're going to be working with multiplication and division. All right, let us begin with this example. A fairly easy example. It's not one of the problems from the book, but I do recommend that you write this down. It is 5x is equal to 30, or 5 times x, here's our variable, is equal to 30. Now, obviously, our variable is not isolated. All right, it is not by itself. Why is it not by itself? What is currently happening to it? It is being multiplied times 5. We want to get rid of that multiplication by 5. So what's the opposite of multiplying by 5? It's dividing by 5. So I'm going to divide by 5, and whatever I do to one side, I'm going to do to the other side as well. Another way to express division is to simply use the fraction bar. I prefer using the fraction bar. I think it's just easier. I think it makes more sense. So I'm going to divide both sides by 5. So I'm going to divide by 5 so I can isolate the variable. Notice what happens when I divide 5. When I'm multiplying and I divide 5 by 5. 5 divided by 5 is equal to 1, and 1 times x is just x, because 1 times anything is just whatever is there, right? Okay, and on this side, 30 divided by 5 is 6. So ladies and gentlemen, x is equal to 6. As always, I can check this by putting it back into the equation. Instead of an x, I'm going to substitute it with a 6. So 5 times 6, and 5 times 6 is indeed 30. So I know that this is correct. Pretty simple. That is the gist of what we're going to be doing today. All right, so again, we're going to be multiplying. We want to isolate the variable by doing the opposite of multiplication, which is division. Whatever I do to one side, I do to the other. And that's how I get my answer. Very good. Now, ladies and gentlemen, we're going to do the same exact example, and in some ways do the same thing, but in a different way. We're going to look at the same problem from a different perspective, because I want you guys to be able to do problems with fractions as well. And so we're going to look at this from a fraction perspective. And so whenever we have any number that is not a fraction, like we have 5 right here, or the number 30, remember that we can always express that number as a fraction by just taking that same number and putting it over 1. In fact, all numbers that are not fractions are over 1. The number 30, 30 over 1. All right, and so let's rewrite this problem as the fraction 5 over 1. Now multiplying this, I'm still multiplying this times x, and then is equal to 30 over 1. I just put the parentheses here to make it obvious that I am multiplying. All right. Now, the awesome thing about fractions here is that there's a shortcut that we can use to get rid of the fraction. Remember, we want to isolate the x. I want to have the x all by itself. I just want the x. That's all I want. So to get rid of this 5 over 1, a very easy way to get rid of a fraction, ladies and gentlemen, is to take that fraction and flip it over. We're gonna use the reciprocal. If you remember that word, reciprocal. I believe that's how you spell it, reciprocal. All right. The reciprocal is simply the flipped version. So the reciprocal of 5 ones is 1/5. So I'm going to multiply it times its reciprocal. Why? Well, remember, I want to get rid of this 5 over 1. And what happens when I multiply 5 over 1, this fraction, by its reciprocal, by 1/5? Well, 1 times 5 is 5. 5 times 1 is 5. So I'm left with 5 over 5. Ladies and gentlemen, 5 over 5 is the same thing as 1. 1 times x is just x. Again, to get rid of a fraction, just multiply it by its reciprocal. Since I had to multiply this side by 1/5, I'm going to multiply this side by 1/5 as well. 30 times 1 is 30. 1 times 5 is 5. 30 divided by 5 is 6. Let me do that once again. So again, when I have a fraction, the way that I can get rid of a fraction is by multiplying that fraction times its reciprocal, its flipped version. In this case, 1/5. All right, that cancels everything there because it's just going to give me 1. And I just have to make sure I do the same thing to the other side. 30 times 1 is 30. 1 times 5 is 5. 30 divided by 5 is 6. X is equal to 6. Now, at this point, some of you guys are going to say, well, Mr. Lugo, everything you've taught us so far, you said that we need to look at the operation and we need to use the opposite operation to isolate the variable. Isn't this 5 over 1? It's a fraction, but we're still multiplying. So why don't we just divide this by 5 over 1 and do the same thing to the other side? Ladies and gentlemen, this is exactly what we did down here. We did divide by 5 over 1. Let me show you. Let me show you how we did that. Let me show you exactly how what we did down here is really still division. And to do that, let's look at, let's take this 5 over 1, divide it by 5 over 1, because remember, the opposite of multiplication is division. So the opposite of multiplying by 5 over 1 is to divide by 5 over 1. But let's take that and do this over here just to show you what's happening. So notice how I have 5 over 1 divided by 5 over 1. Remember that when we have, when we're dividing fractions, we need to follow keep, change, flip, KCF. So I'm going to keep the 5 over 1, right? So I'm going to keep the 5 over 1, check. That's where this 5 over 1 is, I'm just keeping it exactly the same. I'm going to change the division to multiplication, right? Check, I am multiplying, okay? And I'm going to flip the second 5 over 1 into its reciprocal, which is 1/5. Wait, isn't that what I have over here? 1/5. 5 over 1. 5 times 1 is 5. 1 times 5 is 5. Ladies and gentlemen, that equals to 1. It is the exact same thing. What I showed you over here, where we have a fraction, you just multiply it by its flipped version, that is just a shortcut. It is a shortcut. All right, so that instead of having to do this whole thing right here, you just see a fraction, you're like, oh, I know how to get rid of the fraction. Just multiply it times its reciprocal, and you cancel it. That's it. Here, let's do one more example. What if we had something like 1/8, so it's a fraction, times x, notice that I'm multiplying the fraction times the variable, is equal to 2. Well, let's get rid of the fraction because we want to isolate this variable. So how can I get rid of this 1/8? Well, let's multiply it times its reciprocal, which is 8 over 1. The only reason I'm introducing this 8 over 1 is to cancel this 1/8. All right, because 8 over 1 is 8. 8 times 1 is 8. 1 times 8 is 8. 8 over 8 is 1, so that cancels. All I have left over is an x. However, whatever I do to one side, I must do to the other. 8 over 1. 2 is the same thing as 2 over 1, so 2 times 8 is 16. 1 times 1 is 1, so that's really just 16. Notice how simple that is. Again, to get rid of the fraction, yeah, you could say, well, I'm dividing by 1/8 and then do keep, change, flip and all that. Or you can just remember that I can just multiply times the reciprocal. All right. So with that in mind, ladies and gentlemen, let's go ahead and do some of the problems that we had for homework. So let's start with, let's do 7C. 7C, because that one has a fraction, so let's work with that one. So for 7C, we have 4/7 K is equal to 20. 4/7 K is equal to 20. Now remember, my goal is to isolate the variable. I want the K to be by itself. It is not by itself because I'm multiplying times a 4/7. So remember, the easiest way to get rid of a fraction, to get rid of this 4/7 is to multiply. And here, I'm just going to rewrite it so you can see exactly what's going on. So I have 4/7 K is equal to 20. All right, so to get rid of that 4/7, I'm going to multiply it times its reciprocal, which is 7/4. And that's it. You have successfully gotten rid of that 4/7. But since I had to multiply this side by 7/4 to isolate the variable, I have to multiply this side by 7/4 as well. So K will equal to whatever 20 times 7/4 is. 20 times 7 is 140. 1 times 4 is 4. K is going to be equal to 35. All right, you would just divide 140 by 4, and that will give you 35. An easier way to do it, really, if you remember, is we can remember that 20 is the same thing as 4 times 5. And remember that when we're multiplying fractions, if we have the same number in the numerator and denominator, you can always cancel those out. We have a 5 and a 7 left. 5 times 7 is 35. Same answer. Regardless, what I want you to realize is that, again, we can cancel or isolate the variable from the fraction by multiplying the fraction by its reciprocal. That's it. All right, so that was 7C. A and B are pretty simple. You can do those on your own. Let's move on to another one. All right. For 10 and 11, really, I'm more concerned with the actual, not so much with solving the problem, but with actually solving the equation. So for number 10, it says how many egg cartons are needed to pack 216 eggs if each carton holds 12 eggs. So you have this many eggs and you want to separate it into groups of 12. A lot of you guys, to solve this question, all you would do is you would divide 216 and divide that into 12. And yes, that would give you the answer. And that's totally fine if you have a question like this on a test. But let's make this into an equation and solve that equation because that's part of the problem in Schoology, right? That's part of the answer. So let's go ahead. So we have 12 eggs. And we don't know how many cartons we were going to need. But that's going to give us the total amount of eggs that we have. Let's solve this equation. All right. So again, we need to isolate the x. We want to isolate the variable. Since we're multiplying by 12, let's do the opposite. So let's divide by 12. Let's divide both sides by 12 because whatever you do to one side, you must do to the other. All right. 12 divided by 12 is 1. 1 times x is just x. And 216 divided by 12 is going to give you 18. Pretty simple. 11, similar situation. A book of stamps contains 20 stamps. How many books must you buy to get 300 stamps? Similarly, you could just do 300 divided by 20. But they want you to write the equation, so let's write down the equation. It's going to be 20x equals 300. Let's go ahead and solve this. So let's isolate the x. Instead of multiplying by 20, let's divide by 20. Divide by 20. Notice, ladies and gentlemen, that I am dividing 300 by 20. 300 divided by 20. Same as I would if I was just trying to solve the problem. So 20 divided by 20 is 1, so I just leave this with x. 300 divided by 20 is going to give us 15. X is equal to 15. All right, let's focus on number 12. The number 12 is pretty interesting. It reads, 3/4 of the students in the class did their homework last night. If 18 students in the class did their homework, how many students are there in the class? So we have 3/4 of, remember the word of next to a fraction means multiplication. 3/4 of the students in the class. We don't know how many students are in the class. But we know that if we were to take the students in the class and multiply that by 3/4, it would give us the ones that did their homework, which is 18. If you're not entirely sure how I came up with this equation, don't worry about it. I want us to focus on actually solving this equation. All right? So 3/4 x is equal to 18. Again, we're trying to isolate the variable. Do not ever forget what our goal is. In other words, we need to get rid of this 3/4. How do I get rid of a fraction? Remember, just multiply it by its reciprocal. So the reciprocal of 3/4, the flipped version would be 4/3. Why am I multiplying this by 4/3? Because that's going to cancel that 3/4. And it's going to leave the x by itself. However, whatever I do to one side, I must do to the other. So I'm going to multiply 18, or 18 over 1 times 3/4. 18 times 4 is 72. 3 times 1, or 1 times 3 is 3. So x is going to equal to whatever 72 divided by 3 is, which is 24. X will equal 24. Again, a simpler way, in my opinion, to do this. 18 is the same thing as 6 times 3. We have a 3 in the numerator, 3 in the denominator. 6 times 4 is 24. Get the same answer. Again, to cancel a fraction when I'm multiplying, you can just introduce the reciprocal of that fraction, multiply them, do the same thing to the other side. Pretty simple. All right, 14a is pretty simple. I'm going to do 14b because while it's simple, some of you guys have forgotten how to divide with decimals, and so I really encourage you guys to go and review that. I do have videos about that under resources. So we have for set 14b, we have 2.3 b is equal to 36.8. So obviously I need to isolate the variable. Let's isolate this b. How? Well, we need to get rid of this multiplication by 2.3. So let's do the opposite of multiplying by 2.3, which is divide by 2.3, so that we can cancel that. But let's do the same thing on this side. Divide this side by 2.3 as well. So b will equal to whatever 36.8 divided by 2.3 is. Now here, ladies and gentlemen, we need to remember that we do not like to divide with decimals on the divisor. We do not like decimals on the outside. The decimal on the inside is fine. That's not a problem. We can always just bring that decimal up. However, it's the fact that there's a decimal here on the outside that's a problem. So what I'm going to do is I'm going to make this into a whole number. I'm going to move it over. And I had to move it over only once. So now we have a 23. However, since I moved it over once, I must move it over once as well on the dividend. If I moved it 10 times, then I would have to move it 10 times over here. If I moved it twice, I'll move it over twice. Even if the decimal's at the very end, then you would just have to add zeros, depending on how many times you moved it over. You move it over the same number of times. So 23 goes into 36. Well, I'll rewrite it just so you see what we have now. We have 368 divided into 23. It's the same relationship between these two numbers. So 23 goes into 36 once. That's going to be a remainder of 13. Bring down the 8. And 23 goes into 138 exactly 6 times. 23 times 6 is 138. And so b is equal to 16. Please, please, please do not forget how to divide with decimals. We're still going to be doing that. All right. D, E, and F are essentially the exact same thing. All right. So let me do D and E, and then you guys can do F on your own. So when we look at D, we have 3/5 x is equal to 21. Which, by the way, since I'm working with fractions, I might as well make 21 into a fraction already, 21 over 1. All right, ladies and gentlemen, what is my goal? when I have equations, my purpose is to isolate this variable. So we need to get rid of this 3/5. How? How do I get rid of that 3/5? Follow the shortcut. Just multiply it by its reciprocal, 5/3. And whatever I do to one side, let's do it to the other. 5/3 times 3/5, since they're reciprocals, they cancel each other out. It's just 1. 1 times x is just x. And then 21 times 5 is going to be, I can't even think right now, 105. And then 1 times 3 is 3, right? And then 105 divided by 3 is 35. Another way you could have done, so that's the answer, x will equal 35. Another way you could have done this is the method 2 of multiplication. You could remember that 21 is the same thing as 7 times 3. Remember, when you have the same number in the numerator and denominator, that's a 1, they cancel each other out. All I have left over in the numerator is 7 times 5, which is 35. 1 times 1 is 1, so the answer is 35. Simple. Let's do one more. Let's do E together. We have 3/5, once again, times x is equal to 12 over 25. Don't let that fraction scare you. We're not even going to worry about this side right now because the variable is over here on the left side. So let's go ahead and isolate the variable. Let's get rid of this multiplication by 3/5 because it's a fraction. I know I can use the shortcut. Shortcuts are good. Okay, to get rid of a fraction, just multiply it by its reciprocal. Multiply it by its flipped version. And since I had to multiply this by its reciprocal, which is 5/3, I have to multiply this side as well by the same fraction, which is 5/3. 5/3, 5/3. This cancels out because 5 times 3 is 15. 3 times 5 is 15. 15 over 15 is 1. So all I have left over is an x. And then now 12 times 5 is 60. 25 times 3 is 75. Let's simplify these. I can divide each of these by 5. So x is going to equal to 12/15. And that's my answer. That's what I would put on Schoology. Easier way to do this. Remember that 5 times 5 is the same thing as 25. So I can cancel one of those 5s. And all I have left over on top is a 12. And the bottom is a 5 times 3, which is 15. Same answer. That's what I got down here. All right, ladies and gentlemen, I hope you found that helpful. If I didn't do more of the problems, it's because this video is already long and I don't want to overwhelm you. All right, I hope you found this helpful and I will see you next time in class.